All right. Thanks everyone for joining me today. My name is Hossam Barakat and I work as a tech lead with Willow. This is my Twitter handle and website if you would like to follow me or reach out to me with any questions that you have. Thanks a lot for all of the attendees. Please feel free to turn on your camera, and thanks for all of the people that have turned their cameras. We have Dave with his amazing, that's amazing. Thanks, Dave. Today we're going to talk about domain-driven design with EF Core. I have been practicing domain-driven design for a while now, and one of the things that I have noticed when I work with developers is how can they apply all of its value objects, repositories, domain services to their legacy code bases that they have inherited from a previous team or a third-party vendor. And this is going to be the focus of my talk today. How would we apply domain-driven design to a legacy code base? And we will not be only building a domain model that exists in memory, we will also use the EF core to materialize that domain model into a relational database. But before we start, let's go and define what is a domain-driven design. Domain-driven design is an approach to software development that centers the development on programming a domain model that has a rich understanding of the processes and the rules of the domain. So as developers, we will be building a domain model. So that leads us to what is a domain model? A domain model is an object model of the domain that has both behavior and data. So we will end up with a set of classes that will not be just a set of data holders, they will also have behavior. Usually behaviors with object-oriented is functions or methods. So are we going to represent the whole domain that we are working on? Actually, no, because this is the other definition that I really like about the domain model. It's a system of abstractions that describe selected aspects of the domain and can be used to solve problems related to that domain. So we will not be presenting every single aspect that exists in the business domain. We will be focusing on the ones that will help us solve our customer problems. So again, a domain model has behavior, data, doesn't represent the whole domain. The thing to keep in mind is, as we add more and more features to our domain model will keep getting bigger. And having a very large domain model will make it harder to understand and harder to maintain. And this is where the strategic design patterns from domain-driven design help us solve this problem. And the suggestion from domain-driven design is to break that large domain model into a small bounded context or bounded context. So a bounded context is a defined part of the software where you use or you have the terms, definitions, and rules applied consistently. So clear boundary between different parts of the system. So we can see here two bounded contexts, the sales and the support. Both of them have different terms like opportunity, territory. In the support, we have ticket and defect. Both of them could have the same concept like customer and the product, but within each bounded context, the customer is clearly defined. All of the developers and the business experts have a shared understanding of what is the customer mean within that support context or within the sales context. So when we have a large domain model, we should break it into a set of bounded contexts. Today, we will not be focusing on how to break that large domain model into multiple bounded contexts, but we will be focusing on how would we apply the tactical patterns from domain-driven design to a bounded context. But which one should we start with? Domain-driven design shouldn't be applied to all of the bounded contexts that exist in your system, because not all of them will gain value from applying domain-driven design. So if you have a bounded context that is basically crowd operation, like managing a set of categories, you will not get value from applying domain-driven design. Or if you have a product catalog where you are listing the products with their categories and tags and stuff like that, where you don't have any business logic in there, you wouldn't get much value from applying domain-driven design. So keep in mind, not all of the bounded contexts that exist in your system should apply domain-driven design. So which one should you start with? You should focus your domain-driven design on, or you start with the core domain. The core domain is the bounded context that provides the most value to your business. It's that bounded context that if you remove, your business will exist. this is where you should be starting. And when you find that context, this is where you try to apply those concepts like services, entities, value objects, and all of those amazing tactical patterns. Again, this didn't help us to actually see how would we apply those to legacy code. This is just pointed us to where should we start. So in order to apply, I will show you how would we apply the domain-driven design to legacy context or legacy code base. We will use a sample domain to show that as we go. And this is what we will spend the rest doing. So the sample domain that we have is for a florist. That florist have a website, and it enables the customers of the florist to subscribe to products on a weekly or a monthly basis. So a customer can subscribe to a small weekly punch, which will cost them $50. As the customer subscribe to more products and they spend more money with us, we basically give them a discount. This is a simplified domain from a recent project that I worked on, and I kind of took part of that so that we can go through how would we do that refactoring towards a rich domain model. The current domain model that we have in the code base will look like this. We have a customer class, which has email, first name, last name, the amount of money spent, and list of customer subscriptions. We have a list of products or a product where you have amount, name, billing period. And whenever a customer subscribes to a product, we calculate the subscription amount based on the amount of money spent by that customer. If they are eligible for a discount, we calculate when that subscription will end, and then we have a status, either active or cancelled. As you can see, the current domain model, it doesn't have any behavior. And this object model is just data. We have data, email, first name, amount. We don't have any behavior. There is no methods. And this is one of the key takeaways today. The rich domain model that you want to have is a domain model that have a behavior and data. And this is what we will be doing in our refactoring. We will push more behavior towards our domain model. Usually with legacy code bases, the behavior exists in the code, but it's not in the domain model. It could exist in a controller, or it could exist in a service, it could exist in a utility class, it could exist anywhere. And our key objective is to push that behavior, the domain behavior, to be part of the domain model. So we end up with that object model that has both behavior and data. Let's switch to the IDE so that we can read the code base and start seeing how would we refactor it towards a rich domain model. This is a typical code base. It's built with .NET Core that's having the domain, the controller here, which is exposing an API. We will focus on a specific use case today, which is a customer subscribing to a product. So we have a request, and the code base is using the mediator library, which is an excellent library from Jimmy Bogart that enables us to make our the methods in our controllers really small, and we have a specific handler that can handle the request, either it's a query or a command, and this also makes it better from a testing perspective. So the request that we have right now is a subscribe request that has a customer ID and a product ID. I'm passing the customer ID as a parameter because I don't have authentication in this sample code base. And we can see here the handler of that request, which is doing the following logic. Just go to the actual handling part, loading the customer information from the database, loading the product information from the database, calculating the subscription amount based on the product amount and how much did the customer spend in our product. It's simplified logic here. If the customer spent more than $100, they will get a 20% discount. If they spent more than $1,000, they will get 50% discount. Very generous with our customers. So this is where we do the calculation of the subscription amount. The next part here at line 47 is calculating when that current subscription will end, the current period specifically. So if it's a weekly subscription, it will end in 7 days. If it's a monthly subscription, it will end after a month. The next part that we have in this method is creating a subscription. There is a request to increase the font size. I just do that. And just make sure everyone can see it. I hope that's better. Creating a subscription instance, adding the instance to the customer subscription, increasing the amount of money spent. So the next time the customer subscribes to a product, we calculate the discount correctly. The next step is saving all of those changes to the database and sending an email to the customer, letting them know that they have subscribed to a product. So as we can see, this method has a lot of behavior, and this is in this particular case, the behavior exists in handler rather than being part of the domain. And what we will try to do today is push some of that behavior to be part of the domain, while we are applying all of the tactical patterns as we go. Currently, the domain classes exist in this domain directory where we have the customer, product, and subscription. All of my entities inherit from a base entity that is having the primary key or the identifier of this entity. I'm using EF core to materialize the data to the database or materialize the domain model database. Hence, we have a subscription context that has a property for each entity working on. And I'm using the Fluent APIs to map my domain model to the database. And this is important because we don't want to clutter our domain model with any of the ORM concepts. We just want to keep the focus of the domain model on the business part. Hence, having a Fluent APIs is really important. We don't want to have those required table attributes on top of our domain model properties. So this is important. So this is how the code looks like right now. And we have obviously migration and the service of sending data. So how can we refactor this model to be a more of a rich domain model? See, this is a very long method that is doing a lot of logic inside of it. So what I will start with, I will break this method into a smaller methods. In legacy code bases, you might have some hints like comments or regions that help you identify how to break that large method into smaller methods. So we'll break this logic to a smaller set of methods. So the first one here is pretty easy, calculating the subscription amount. So I'll extract a method from this. Then I will extract another method for calculating the current subscription period in date. The last part is basically creating the subscription, adding it to the customer. So let's create another method and we will call it add subscription to customer. All what we have done is we have simplified the method that we are refactoring, which basically minimize the cognitive load that we have in order to understand this method. All right, let's go and view each of those methods and see what are the issues that we have and how we can push that behavior to be part of the domain model. The first method here is adding a subscription to customer. I can see a few issues with this method. The first one is the creating a subscription itself is done via the object initializer. And this means the model can do those mistakes of, instead of creating the subscription in an active status, they can go and create it in cancel. And although from a code perspective that's valid, from a business perspective that's wrong. You should never create a subscription that's in cancelled status. Subscription always starts with active. So the domain model is not stopping the consumers from making those mistakes. Similarly, I can create a subscription without a customer or without a product, right? And I will not get any exceptions from the domain model. I might get an error when I try to materialize the domain model into the database, but we should have all of those business logic or business behavior to be part of the domain model. Thankfully, with C#, we can use the constructor feature to encapsulate that logic to be part of the subscription. And instead of having those publicly set properties, they can be privately set, which means we can modify them only via behavior that exists in the domain model itself. So I have a code snippet for that. So here is my subscription constructor. I have created a new instance of a new constructor that accepts the required parameters to create a subscription. And as you can see here, I started applying validation to my constructor. So if I try to create a subscription without a customer, I will get an exception. If I try to provide a negative amount, I will get an exception. And as you can see, I have immediately set the status to active, and the consumer domain model doesn't need to worry about that. Since I have updated the constructor, let's update the consumer code to use that parameterized constructor. So here we go. So we have pushed that construction behavior to be part of the domain model. I have a single test here that will help me. I didn't break the code. Obviously, in existing code bases, you might have more tests. And if you don't have any tests, then this is maybe what you should start with, which introducing tests to your code base. So let me run the test to make sure nothing is broken. I'm getting an exception here, and the exception would say there is no suitable constructor. And the reason is this is a limitation from EF Core, because EF Core cannot create an instance of an entity that has a parameterized constructor, specifically when you have parameters in that constructor that are navigation properties like customer or a product. And the solution to that is to introduce a private constructor, because we don't want the consumers of our domain model to use that parameterless constructor, but it can be used by EF Core. Some people would prefer to have a separate domain models, separate models, one domain model to include all of the behavior, and another all of the persistent logic, like to avoid having stuff like private constructor. In my opinion, with all of the improvements that are coming to ORMs like EF Core, I don't think this is a big issue, and I think it could be okay to keep progressing with a single domain, because this is not really like a big to my domain model. So let's run the test now and make sure nothing is broken, and EF Core can construct that subscription entity. Are passing, and now we have pushed that behavior to the subscription class. The next thing that I can see here with this subscription class is that the developers consuming subscription need to always remember to update the amount of money spent whenever they add or remove or change the subscription collection. So this relationship is basically needs to be always kept in mind whenever you work with the subscriptions list. And the way I see it, that this behavior is something that could be pushed to be part of the domain model. And consumers of my class shouldn't even need to worry about modifying the money spent. It should be a read-only property, and it should be modified via behavior within the class. So I can push this whole behavior of adding subscription to a customer to be part of the customer class. Like, this is how would I add a subscription to a customer. I will add those parameters, and this behavior of modifying the money spent become part of the customer. So let's do that. I will use the refactoring that I have from Rider, and I will make this add subscription to customer to be an instance method in the customer class. So now we have it part of the customer, and we can rename it so we don't have that two customers, since we are part of the customer already. Since I have moved the behavior to be part of the customer, I can modify the money spent to be privately set rather than publicly set. So the consumer right now doesn't need to worry about updating the money spent whenever they add a subscription to the customer. So we have done a refactoring. Let's run the test to make sure nothing is broken. There are different approaches when you work with this refactoring. Some people prefer to use a factory method. That's also an option. If you want to have or like domain services option, it depends on the business. and it depends on the case that you have here. So in this case, I think adding a subscription is working fine. But again, the consumers cannot go away with, or actually can go away with doing something like this. Subscription clear. The consumers of the subscription class can still go and modify the list of the subscriptions. And this will break the relationship between the money spent and the subscription collection. So what we can do here is we can go and modify our customer class. So instead of exposing a mutable list, we can expose a read-only list. So what I have here is a list class, is using the list class, which inherits from iReadOnly, and iReadOnly inherits from iReadOnly collection. So I can expose iReadOnly collection and use a packing field rather than exposing a mutable list. So I have a little code snippet for that. So you don't need to watch me writing, and I will update my method to use the private field. So I have exposed iReadOnly collection, and I have a private field which is holding that list right now. At this point, although I don't have that clear method exist, but nothing stopping me from casting this subscriptions to be a list of subscriptions, and then I can call the method. If I do this right now, it will work, and that wouldn't be an issue. And to avoid having that scenario and cover it as well, we should be using a method that's called asReadOnly. And this will be a wrapper around my list, and it cannot be modified in the runtime. So right now, if I try to call this clear method, I will get an exception. So now we have behavior to be part of my customer class, and no one can break that relationship between subscriptions and the money spent. And whenever I want to modify the subscriptions list, I can do it via the private field. Let's run the test and make sure nothing is broken after the refactoring. Right, passing. So let's recap what we have done so far. The first thing that we have done is we have broken that very long handler to have a smaller methods. So we had a method for calculating subscription amount, the current period end date, and adding subscription to customer. We started refactoring the add subscription to customer. First, we moved the behavior of constructing a subscription to be part of the entity itself, and we used the constructor to validate the parameters coming to the subscription. Also encapsulated the logic of adding subscription to customer to be part of the customer entity. And we encapsulated the behavior of modifying the subscription and money spent, so both of them became read-only. The money spent is via private set, so you can read the value, and we encapsulated the behavior of the read-only collection using asReadOnly. So now more behavior moved from the handler to be part of the domain model. Let's get back to our handler and see the next method that we have extracted and what do we have in here. This method is interesting because it's a static method, which is calculating the current period end date. It's a static and accepts a single parameter, which is the product. Whenever I see this pattern of having a static method with one parameter, this usually could be an indication that the whole behavior belongs to the product. So instead of having the behavior as a part of the handler, we can move this whole behavior to be part of the product class. And this is what I'm going to do. So I move this behavior and I'll make it an instance method of the product. So now it's part of the product. One thing to keep in mind here is we can see there is a switch statement on the billing period, and the billing period is an enumerator. In the legacy code bases, one of the smells that you might find in the code base is there could be multiple locations in the code base where you could have multiple switch statements or if-else conditions on that particular enumeration. And the problem with that is if you would like to introduce a new value for the enumeration, like in this case, introducing a yearly subscription, it would mean that you would need to go and update all of those touch points in the code. One thing you can do if you have that case is refactor this enumerator to be an enumeration class and refactor those switch statements to be part of a strategy pattern implementation. I wouldn't show you that today because we don't have the case, but if you are interested, the code is available in GitHub and will show you of this sample is available in GitHub with a sample of refactored enumerator to enumeration class. I will reference the link of the source code at the end of the talk. So for this case, we will just keep it as a part of the product and we'll just run the test to make sure nothing is broken. So nothing is broken, that's amazing. Let's start looking at the next method that we have here, which is calculating the subscription amount. Calculating the subscription amount is it's a static method and it has two parameters. The first is the product and the second one is the customer. So we cannot basically just move it to one of the entities because maybe in this case we don't have the behavior to fit well into one of the entities. And the domains becomes very handy, which is basically it's a class that could have a behavior that doesn't belong to one particular entity. And it could be accepting the input as multiple entities, work the behavior in there, and return the outcome. And this is what I'm going to do today. I will introduce a domain service to calculate the subscription amount. So I'll go here, create a class. We'll call it subscription amount calculator. And this class will be the one to hold the behavior that we have in our request handler. So I will use the refactoring from ReSharper to move this behavior to be part of subscription amount calculator. And ReSharper is a bit slow because I'm streaming, but that's fine. Found our class. And we move it to move this behavior to be part of the subscription amount calculator. Since we are working with classes, I would prefer to develop against an interface because it makes my testing easier. So what we will do is we will make this a non-static method, and then we will extract an interface of this class. So we can do that by extract an interface, and we'll call it, it's already have the I. And we can push this member to member up, and it will be part of the page interface. So now I can update my handler to accept the interface as a dependency and then use that domain service dependency to calculate the subscription amount rather than using as a part of the code. So subscription amount calculator, then we'll call it here, introduce private field, then we go with, and now we have a new dependency, and obviously we need to update the test to use this new domain service. So I'm just gonna go and we'll pass this dependency in here. One thing to notice after introducing that dependency is the outcome of this dependency is passed to add subscription of the customer. And also the add subscription is accepting product. So inside this method, I have the product and the customer at the same time. So what I can do, I can take this one little bit further, which is pushing that behavior of calculating or calling the calculate method in the subscription amount calculator to be part of my domain. So rather than passing the outcome, I can pass the actual calculator and use the double dispatch pattern of passing the customer and the product to the domain service. So what I will do here is I'll do this by changing this method to accept subscription amount calculator. Just that, and instead of using the subscription amount directly, just create a variable here. We'll be basically holding the value of calling the domain service. I will be passing the product, which I'm already getting as a parameter, and then I will pass the customer, which I am part of the customer already. So at line 19, I'm passing an instance of the customer class to the domain service. This means the whole calculation of the subscription amount doesn't need to happen as a part of the handler. It will happen as a part of the domain logic itself. So now I have behavior, and I should run the test to make sure that I didn't break my method. Right, the tests are passing. Let's go and recap what we have done so far. After encapsulating the collection, we pushed the behavior of calculating the current period in date to be part of the product class. We talked about the potential of usage of the enumeration classes if you have multiple locations in your code base with if, else, or switch statements over the enumerator. The next thing is we have introduced a domain service, and that domain service had the logic of calculating subscription amount. And the reason we introduced the domain service is that behavior didn't belong to either the product nor to the customer. Finally, we use the double dispatch to pass or to call the domain service as a part of the domain logic rather than as a part of the handler. So as you can see, our handler had all of that logic as a part of it, and most of that logic were belonging to or better to be pushed to the domain model, because now we have a richer domain model with more data and behavior rather than data only. The next thing that I can see in this handler class is sending an email to the customer. Obviously, it's very simplified. It doesn't even actually send an email, but it's just to give the idea when something happens in the domain, like a customer subscribed to a product, as an application, we would like to notify the customer that they have subscribed to that product. So sending an email is definitely part of the application, but instead of doing as a part of the handler itself, we can trigger that email sending activity or function once a domain event happened in my domain. So this is where the domain event concept becomes in handy. And the way we can introduce the to our domain is let's go switch to the slide and we'll show you how it will actually work. So all of my classes inherit from a base entity. So what I would like to do is whenever an action or behavior happen in my domain entity, to add or raise a domain event. And I will raise that domain event by having a list of domain events in the base entity. And whenever the action is called, I will add an entry to that list of domain events. Then whenever the DB context save it changes method is called, we will be leveraging the EF5 save it changes interceptor to listen to that behavior that the save it changes method has been called. Then we will be leveraging the DB context change tracker to find all of the entities in the DB context that has a list of domain events. We'll loop over those entities, and we will be using the mediator library to publish those domain events. The publish method from mediator enables us to have that pub/sub mechanism, and it means I could have handlers listening to that domain event and processing the logic required for that domain event. So if we have a domain event called customer subscribe to a product, then we can have a handler that will send an email to that customer, or maybe send an email to the shipping or to something else. One thing to keep in mind, as you can see, I keep using the past tense when I'm describing my domain events, and this is what you should have in your classes, because domain event is used to describe something that has happened in the past, something that is already happened. So my domain events usually use the past tense in their names. So let's see how would we actually go and see this in action. First of all, we need to introduce a base interface that can be used by all of the domain events. So in the shared kernel here, I will create an interface and we'll call it iDomainEvent. Since that domain event is going to use the mediator, I am going to make it inherit from iNotification class from the mediator library. then I will update the base entity to have a list of those domain events. So we have a read-only list, and we have a few methods that enables us to update or modify those domain events. So the entities that inherit from the base event, whenever behavior happens, like a customer subscribe to a product, they can add that event to the list of domain events. I will create a new directory to hold or namespace to have my events. And I will create a class called customer subscribe to product. This is going to be my first domain event. And then this should inherit from I domain event. I have a code snippet showing the actual domain event with the handler of it. So let's have that. Remove the domain service. Here we go. Here is the actual domain event. And the parameters of that domain event or the properties of the domain event is the customer that subscribed to the product and which product they subscribe to. Using inotify handler from mediator, so whenever that domain event is raised or published, we can listen to that domain event here. And as you can see here at line 27, I am sending the email. The last part to do is when the customer subscribes to a product, not the last part, the next part is raising that domain event. So we will add a customer subscribe to a product event here. So I'm calling the method from the base class called add domain event, which will basically add to that list of domain events. So what we have done so far is updating the base entity to have a list of domain events. We have introduced an event with an event handler. The last bit of this changes interceptor, which is going to use the EF core 5 functionality, which I have cheated a bit here, and I have that class commented out. So I'm going to uncomment it, and let's read the code together. So in order to listen to those save changes events from EF core, you can inherit from a class called save changes interceptor. Save changes interceptor can be registered to the dependency injection framework that you are using, and hence you can inject any dependency that you have in your code. So hence I'm injecting the mediator in my construct. Then this base class enables us to override the save changes and the async method of save changes async. Whenever the save changes method is triggered, this will enable us to dispatch the domain. You can see here at line 36, we are using to find all of the entities in the context that have domain events inside of them. Then the next step here is looping over those entities and finding the domain event using mediator to publish those domain events. One of the things to keep in mind when you have this pattern is the resiliency. What happens if you sent an email and you fail to save the database changes, or you save the database changes and you fail to send the email? The order of events here is important. Usually the next step when I work with this pattern is I separate those behaviors into two separate processes, and I use a pattern called the store and forward, or it's also called an outbox pattern, where instead of immediately publishing the domain events, I save the domain events into a table in the database, and then I have another process that read those events and basically process them or publish them to a service bus to be processed by the consumers. We will not do that today, but this is something to keep in mind when you work or start introducing domain events. Since we have introduced a new class, we need to make sure that that class is registered in our DI container. And the domain event dispatcher can be registered as a scoped service. And when we add the DB context from AF core, we can use the overload that accepts a service provider, which means we can call a method called getService, and that will mean that the domain event dispatcher will be resolved from the DI, and not only the class, it's also all of the dependencies in that class. Now we have everything in place. We should be able to run the test. I don't have really tests covering all of those areas, but I just want to make sure that the behavior hasn't been broken. Ideally, you should start having more tests, like tests for domain event dispatcher and the actual domain event. The actual domain event handler, I should say. And since we have introduced the domain event handler, I can remove this whole logic of sending the email from my handler because it's no longer required here. I can remove this email sender. It's now handled via event handler. So my logic is much simpler right now, and even my test will be simpler because yet another dependency removed. Running the test and everything. Great, nothing is broken. So let's recap what we have done because I know this is a little bit involved. We have added the list of domain events list using the save changes interceptor from EF45. Save changes, using the change tracker to find all of the entities that has domain events in them, publish them to the mediator, having the event handlers to handle those domain events. So far, all of the refactorings that we have been doing were triggered based on smells in the code, like having a method with a single parameter or having a behavior that's stopping the consumers from constructing an entity in the right variant, basically. But this is not always the case when you work with domain-driven design, because one of the important things with DDD is having a continuous collaboration with the business experts. We should try to make your domain model use the same language used by the business experts. And this is where the ubiquitous language part becomes really important. So some of the refactorings will not be triggered from code smells, it will be triggered from the conversations that happens with the domain experts. A simple example within the tactical patterns is, let's say we are talking with the business experts and they always use the term, I want to show the customer name in the reports. I want to show the customer name in this particular thing. And they keep using that customer name all the time, but they never go and say, I want to show, they never talk about the customer name in terms of customer first name, middle names, last name, or customer first name, last name. They always just refer to the customer name. So at that point, it might be a good idea to start using value objects to represent the same concepts or the same or use the same language that the business experts are using. So instead of having customer first name, last name as a part of my customer class, I can refactor that to use a value object. Value object as a concept means if we have two instances of a value object, both instances will be equivalent if all of the properties of the value objects are equivalent. So this is basically lends itself well with the C#9 records. It's pretty much the exact definition. So what we can do, instead of using first name, last name, we can introduce a record as our value object. So what we can have here is CNAME record. There's going to be some highlighted alerts here because JetBrains Rider doesn't support C# records fully yet. So ignore those highlighted errors. As we will see when we run the test, it will be working fine. So now we have created the customer record. I can use that customer record in my class. And even better, as we have done with the subscription, I can introduce a constructor and pass that customer name as a parameter of my constructor. So I will remove those properties and will replace them with constructor and privately set properties. So here is my private constructor to be used when loading the data from the database because of EF core limitation with parameterized constructor. I can pass the customer name as a parameter of my constructor, having my validations here. And here is my property. It's privately set and can be modified only via methods within my customer because this is part of the behavior. Now we have introduced the customer name. I should update my test to use the customer name and the constructor that we have introduced. Use the wrong constructor. So here is the constructor, and we can see that the test should be passing right now. But actually the code wouldn't compile because we didn't do the configuration of how would we customer name record to be using the same fields in the same table of the database. And this is where the core own entities becomes really important and valuable feature that we can leverage. So instead of directly using the builder here in the Fluent API, I can go and say owns one, not that one. So builder.owns one. This enables us to introduce a value object or map a particular property, and then within that owns one we can define the properties within this builder is mapped columns in the same table. One thing to keep in mind here is the default naming conventions of owned entities is the table name underscore the column name. So if you are working with a legacy code base, probably you need to use the explicit column name. And one of the benefits of using AF Core 5 is now, previously with AF Core previous versions, the default behavior of owned entities that they were nullable. But right now, this is with this navigation method, we can define if it's optional or required. And also we can define for each column if it's optional or required. And if you generated migrations or either a SQL or a code migrations from this owned entities, it will be mapped correctly. Now the mapping is done. If we run the tests, it should be passing. Let's run that. Amazing, the test has passed. So let's recap what we have done so far. After domain entities, we moved away from using the primitive parameters like the string for string first name and string last name to value objects, and that enabled us to have a domain model that is using a consistent language and the same language used by the business experts. We have also used the owned entities to map those properties to the same columns in the database table. And we leveraged the new navigation method from AF4 the database that those columns or this property is required. The next thing that I want to talk about is in my code base, you haven't seen any repositories. And usually one of the things that I have seen with legacy code bases is repositories all over the place, repository per entity or generic repository. And this is a sample of a repository that you might see in a legacy code base. You could have something, a repository for a customer where we have get customers, get customer by ID, and save. Usually these repositories are okay, but sometimes they have landmines like this save method. Because save method here is calling the context save changes. And context save changes will send all of the changes not only relevant to the customer entity, to any entity to the database. And this means if I have a service and that service is consuming multiple repositories at the same time and calling the save method in each repository, we might be calling the database multiple times unintentionally. So this is something that you should be aware of. In some solutions that I have seen is introducing the unit of work pattern to avoid having save method in each repository. And you would have something like this. You would have a unit of work. The unit of work depends on the subscription context or the DB context in general. And then you have a save method that's calling the context save changes behavior as a part of that unit of work. That could be a potential solution. But in my mind, this solution is introducing unnecessary dependency because the subscription context itself is a concrete class that we are owning and maintaining. So instead of introducing yet another unit of work class, we can embrace the subscription context to become our unit of work. And that would be the one that would have all of that save changes, commit, begin transaction, rollback, all of those behaviors that we would like to have as a part of the unit of work. And if we are worried about the unit testing part, we can leverage an interface, and we use the interface as the dependency that we inject to all of the consumer classes. The queries, queries to read data like getting the customer or getting the subscription and so on. The queries in general, one of the things that I have seen when you use the repository pattern is you end up with those very big repositories that have get customer by first name, get customer by last name, get customer by first name and email, and so on. There are other solutions out there that could help with improving and solving those problems. Unfortunately, we wouldn't have enough time to go over each of them, but I'll give you the name of the patterns so you can look them up after the talk, and I'm happy to show you examples of them. So the three patterns that I think would help you having a solution and avoid that big repository class is using something like the query classes or a specification pattern or the extension methods. Those patterns will try to make like specific queries or the reusable queries encapsulated, and you can use them in multiple places, but at the same time, you wouldn't end up with very, very big repositories. There are a lot of samples out there about those patterns. Fortunately, we will not be able to go through all of them today. The next thing that I want to talk about is the entity identifier. As you have seen in my code base, I'm inheriting from a class called entity, and in your code, you might have a different type. You might not have a GeoID. If you are working with the legacy code base, it might be integer. Or sometimes I have seen some entities with integer, and the newer entities are with GeoID. So you could make that base entity class a generic class that accepts any type of identifier. And even better, move away from having a specific primitive type or like integer and use a strongly typed identifier, like using a value object to represent the identifier of your entity. So for customer, you could have a customer ID. Subscription, you could have a subscription ID. The good thing with using those strongly typed identifiers is first, we can introduce validations in the constructor of that value type. So if I have a GeoID, I can ensure that the GeoID is not an empty GeoID. So adding a validation, you never have a identifier. The other thing is if you have a method that accepts multiple identifiers, you wouldn't have the mistake of passing the GeoID of the product to be the GeoID of the customer, because it's a strongly typed language and we can leverage that feature when we are building our code base. Finally, if you have a legacy code base and you're refactoring from, let's say, integer to GeoID, you wouldn't need to update your whole code base to move from integer to GeoID, because your code base would be using that strongly typed identifier. So primitive behind the scene, using it as a strongly typed value option. So that's something to keep in mind. You might not be able to do the first step when you are refactoring your legacy code base, but it's something to keep in mind and you should be aiming towards as you progress with your improvements. That's all what I wanted to cover today. I will be looking for the questions over the Slack channel. If you have any questions, please put them there. I will also share the slides as well as the sample code that we have seen today in the Slack channel. And since I want to thank all of you and Microsoft Australia for sharing some cool swag with you. So those are the first link is a link to join a newsletter, and it has a lot of valuable information. If you want to grab the cool swag, you can go to that link of from Microsoft, and you can use the code available here to gain your swag. It's going to be for only the first 4 entrants. So not everyone will get the swag, but hopefully 4 of you will get that swag. Thanks again for your time. I hope you enjoyed the talk, and Yeah, I hope you enjoyed the rest of the conference today. Thanks a lot.